We imagine emptiness as a kind of peace, a silent room where nothing moves, nothing breathes, nothing waits, a darkness so complete it feels like the universe exhaled and simply never inhaled again. But this is only the illusion our minds were trained to see, because the deeper we look, the more that silence begins to crack. What we call nothing trembles with invisible motion, with restless fields humming beneath perception, with quantum sparks flashing into existence only to vanish before a thought can form. And so the void is not a void at all. It is a stage of endless possibility, crowded with things that refuse to be seen. But if even emptiness is alive, then something inside us must shift. The boundaries between what is and what isn't blur, wobbling like a mirage at the edge of understanding. Maybe the universe has never tolerated true stillness. Maybe it has always been filled, even at its most silent, with the potential to become everything, which leaves us with a question that unsettles the ground beneath our certainty. If emptiness cannot exist, then what was the universe before the universe? We have always been afraid of nothingness. Long before science existed, before telescopes traced the sky and mathematics carved order out of chaos, humans stared into the dark and felt an ancient shiver run through the spine of imagination. What terrified us was not the creatures hiding in the shadows. It was the possibility that nothing might be hiding there at all. A space without breath, without sound, without meaning. A place the mind could not hold because it offered nothing to grip, nothing to measure, nothing to understand. And so, from the very beginning, the void felt less like a concept and more like a threat, a ghost shaped by absence. Early civilizations tried to banish this threat by filling their worlds with gods, spirits, and eternal fires. The Mesopotamians imagined a cosmos wrapped in living waters. The Egyptians saw the sky as the body of a goddess stretched protectively above them. To ancient cultures, emptiness was not just unnatural, it was impossible. The universe had to be full, because emptiness was a kind of death, and death to them was a wound that swallowed everything it touched. But even then, in the quiet spaces between their stories, a deeper unease lingered. What if beyond the circle of firelight, beyond the dome of the heavens, there truly was a place where nothing existed? The Greeks were the first to stare directly at that question. They stepped into the unknown with reason as their lantern, and what they found unsettled them. Parmenides insisted that nothingness could not exist because to speak of it was already to give it being. Democritus imagined atoms falling through the infinite void, but this void wasn't true emptiness. It was simply the stage on which atoms danced. And then came Aristotle, whose influence would echo for 2,000 years. He declared that a vacuum was impossible, that nature would rush to fill any gap the moment it appeared. Horror vacui, he called it, nature's fear of the void. But the truth is simpler. It was our fear projected onto the universe. For Aristotle, the void threatened the harmony of his cosmic model. In his world, everything had a place, a purpose, a motion ordained by logic. A vacuum introduced chaos. It meant a space where laws might break, where movement could lose meaning, where the order of nature could fracture. And so the void was exiled from the universe, not because nature abhorred it, but because humans did. The Greeks hid their fear behind philosophical certainty. They built a cosmos of spheres and elements, a world with no room for emptiness. because emptiness reminded them of the limits of their own understanding. Centuries passed, empires rose and fell, and Aristotle's fear endured. Medieval scholars inherited his universe and defended it with a zeal born of both faith and instinct. To them, a vacuum was not just physically impossible, it was theologically dangerous. If there was a place where nothing existed, then there might be a place where God was absent. And so the void became a forbidden idea, a concept locked behind doctrine and preserved by the inertia of human comfort. To question emptiness was to question the structure of creation itself. And so the world was declared full of matter, full of purpose, full of divine presence. But beneath that certainty, the fear continued to whisper. Why do we fear the void so deeply? Perhaps because nothingness is the enemy of meaning. Our minds evolved for presence, objects to grasp, dangers to avoid, tribes to recognize. Every instinct we carry was shaped in a world overflowing with stimuli, forests, rivers, predators, signals. Emptiness offers none of that. It offers no clues, no patterns, no stories. And so when confronted with the void, the brain flails. It cannot categorize, cannot predict, cannot survive in a place where there is simply nothing. In a world of danger, emptiness was not merely unfamiliar, it was unusable. And the mind, shaped by survival, turns away from whatever cannot help it survive. Even language betrays this fear. We speak of nothing as if it were a thing, an object we can point to. But the moment we point, the moment we imagine, we fill it. Absence refuses to stay absent. We populate the void with monsters, myths, or mathematical symbols. We cannot leave it blank. Our imagination rushes into emptiness the same way Aristotle believed nature did. And perhaps that is the real horror vacui, not nature's fear of emptiness, but ours. Still, the void persisted at the edges of human thought. In the Renaissance, a few rebellious minds dared to question the old dogma. Galileo imagined falling bodies in a space without resistance. Descartes argued that a vacuum was unthinkable because extension required substance. A philosophical attempt to hold the void at bay, but some thinkers felt the pull of the unknown. Torricelli, a student of Galileo, created the first artificial vacuum using mercury in a glass tube. He watched the space at the top of the tube, silent, airless, unsettling, and declared, "We live submerged at the bottom of an ocean of air." This was a revelation so simple yet so profound that it cracked the ancient fear open. If a small, controlled void could exist in a tube, then what else was possible? And what else had we been wrong about? But even as the scientific world began to accept the vacuum as real, the emotional world lagged behind. The idea of nothingness continued to haunt us. Poets described it as a devouring abyss. Philosophers wrestled with the logical paradoxes it created. Theologians warned against its theological implications, and everyday people staring into the night sky felt a tremble that had nothing to do with stars. Because to imagine nothingness is to confront our own fragility. If the universe could fall back into nothing, then so could we. If emptiness existed before creation, it might exist after us. And if the void is the true canvas of reality, then everything we know, life, memory, beauty, is only a fleeting arrangement painted onto a deeper silence. The void forces us to acknowledge the temporary nature of existence. It whispers that we are not permanent, not inevitable, not guaranteed. And so humanity clung to fullness. We filled our cosmologies with purpose, our physics with certainty, our religions with meaning. We built mental worlds as dense as the forests our ancestors walked, because emptiness is a mirror that reflects our deepest fear, the fear that we might not matter, the fear that the universe does not require us, the fear that existence is not the default but the exception. Yet slowly, inevitably, the truth began to shift again. By the Enlightenment, the vacuum was no longer a philosophical enemy but a physical reality. Experiments revealed that air could be removed from a chamber, that objects could fall unimpeded, that sound could not travel without a medium. These discoveries transformed nothingness from a mythic terror into a measurable phenomenon. But even then, physicists believed that a vacuum was simply empty, a place where matter did not exist, a blank stage waiting to be filled. What they did not yet know, what they could not yet imagine, was that the void was not empty at all. Humanity's oldest fear was about to collide with the universe's deepest truth. Because even as we began to conquer the idea of emptiness in our laboratories, the cosmos was preparing to reveal something far more unsettling. That the vacuum we thought we understood was only a shadow of a larger mystery. That space itself, the very fabric of reality, was alive with fields, fluctuations, and impossible energies. That nothingness was hiding everything. And so our ancient fear, rooted in myth and instinct, would soon evolve into wonder. The void we once dreaded would become the frontier of modern physics. And the question that haunted the Greeks, the scholars, and the dreamers would lead us to discoveries they never could have imagined. But before that transformation could begin, humanity needed to face the truth that had been waiting across millennia, a truth whispered by glass tubes and falling bodies, by forbidden philosophies and trembling imaginations. The universe was about to reveal that there is no such thing as empty space. For thousands of years, humanity believed the void was simple. If you removed the air, removed the dust, removed every wandering atom, you would eventually reach a perfect silence, a vacuum that was truly nothing. It felt intuitive, it felt clean, it felt final. But intuition has always been a fragile guide through the cosmos. And as the 20th century opened its eyes, the universe began to whisper a deeper truth, a truth so strange that even the greatest minds of the age hesitated before it. Nothingness could not sit still. This revelation began quietly, almost innocently, with a mathematical rule that should have been a footnote in the history of physics. Werner Heisenberg, a young man wrestling with the ghost-like behavior of electrons, discovered something unsettling. There are limits to what can be known, not because our tools are crude or our methods imperfect, but because nature itself refuses to be nailed down. Position and momentum cannot both be exact. The more you know of one, the less you may know of the other. Reality flickers between answers. Certainty dissolves. This was the birth of the uncertainty principle, a law not about ignorance, but about existence. And its implications were devastating. If particles cannot be perfectly still, then the vacuum that holds them cannot be perfectly calm. Even at absolute zero, even when all energy is stripped away, tiny tremors remain. A shimmer beneath the silence, a heartbeat beneath the void. Suddenly nothingness had a pulse. What Heisenberg revealed was not merely a flaw in measurement. It was a fracture in the foundation of classical thought. The universe did not behave like a machine with gears and levers. It behaved like a storm made of probabilities. And in that storm, even the emptiest space was alive with motion, jittering, vibrating, refusing to freeze. But this was only the beginning. As quantum mechanics unfolded, a new picture of reality emerged. What we once called empty space was discovered to be filled with fields, not metaphorically, but literally. Quantum fields stretch across the universe like invisible oceans, each one corresponding to a type of particle: the electron field, the quark field, the photon field, the Higgs field. These fields are not optional, they are existence itself. Particles are simply waves in these fields, ripples rising from an unseen sea. A vacuum, then, is not the absence of things, but the lowest energy state of these ever-present fields. A calm ocean, not a barren wasteland. And even in their calmest state, these fields cannot stop moving. They quiver with zero-point energy, the irreducible restlessness built into the fabric of reality. The vacuum seethes, it breathes, it glows with potential too faint for the eye, but too fundamental to erase. Physicists began to realize that emptiness was an illusion born of scale. At human sizes, the vacuum appears still, but magnify it a trillion times, and the calm surface breaks apart. Particles flare into existence, then vanish before they can be named. Antiparticles mirror them, annihilating in sparks that flicker faster than imagination. This is not science fiction. This is the vacuum as seen through the lens of quantum electrodynamics, a churning ocean of activity beneath the quiet of space. It is a truth that feels impossible, but impossibility has never stopped the universe from being real. John Wheeler, a physicist who saw beyond boundaries, pushed this vision further. He imagined space-time not as a smooth fabric, but as something far stranger, a froth of constant creation and destruction. At the smallest scales, space-time itself wavers, fluctuates, folds in on itself like a restless tide. He called this quantum foam, a sea so turbulent that even geometry breaks apart. Length loses meaning, time flickers, causality stutters. The cosmos becomes a boiling cauldron of uncertainty. In Wheeler's foam, the vacuum is no longer empty space. It is the birthplace of all possibility, a horizon where universes could flicker into being like sparks from a fire. This idea was not poetic flourishment. It was mathematics sharpening the knife of reality. The closer humanity looked, the more we realized that emptiness was the most active environment imaginable. Virtual particles emerged uninvited. Energy densities danced, fields hummed. The vacuum behaved less like a void and more like a restless engine capable of reshaping the cosmos. But how could nothing produce anything? How could the absence of matter generate motion, energy, structure? The answer lies in the paradox at the heart of quantum mechanics. The vacuum must fluctuate. To force it to stop would violate the uncertainty principle. And so even in perfect stillness, the universe refuses to be still. Even with all energy removed, a remainder remains, a leftover, a whisper of existence embedded in non-existence. This whisper shook the foundations of physics. It meant that the vacuum wasn't empty. It was the default state of everything. And if this state seethed with activity, then perhaps the universe itself emerged not from a pre-existing substance, but from the vacuum's own instability. The Casimir effect provided the first haunting proof. When two metal plates are placed extremely close in a vacuum, they are pushed together, not by air, not by static, but by the vacuum itself. Virtual particles and fluctuating fields exert pressure. The void applies force. Nothingness behaves like something. Humanity watched as one of its oldest assumptions crumbled. Even Einstein, who resisted quantum strangeness, left his mark on this revolution. His cosmological constant, originally a mathematical fix to keep the universe static, turned out to describe the energy of empty space itself. What he once dismissed as his greatest blunder became a doorway to understanding dark energy. The vacuum's energy is not trivial. It shapes the expansion of the universe. It determines the fate of galaxies. It is the engine that drives cosmic acceleration. The vacuum is not passive. It commands the cosmos. And so the void, once feared for its emptiness, became feared for its fullness. Humanity had stumbled into a universe where the calmest places hid the wildest behavior, where nothingness was more powerful than matter, where the background of reality was not stillness, but agitation, a place that could create particles from the tremble of uncertainty, a place that could ignite the beginning of everything. The implications stretch beyond physics into philosophy. What is nothingness if it contains infinite potential? What is emptiness if it constantly creates? What does it mean for existence if non-existence refuses to exist? Our ancestors feared the void because they believed it was empty. Now we fear it because it is not. And still the mysteries deepened. If virtual particles can appear and disappear, what prevents a universe from doing the same? If vacuum energy permeates all of space, what could it become under the right conditions? If quantum foam devours the smoothness of space-time at microscopic scales, could it have erupted outward in a single moment, inflating into the cosmos we inhabit now? This is where the story begins to tremble at its own edges, because the deeper we wade into the quantum sea, the more violent the water becomes. Fields shake, energies collide, possibilities burst open like stars. Nothingness becomes a storm, stillness becomes turbulence, and the vacuum becomes the most unpredictable medium the universe has ever known. Scientists today understand that the vacuum is not a backdrop, but a player in the cosmic drama. It dictates interactions, it shapes forces, it gives mass, it bends space-time, it sculpts the evolution of everything that exists. Without the quantum vacuum, particles would not form, atoms would not hold together, stars would not burn, existence would collapse into silence. But the vacuum will not collapse. It is never silent. It boils with the energy of potential. It seethes with the tension of creation. It waits not idly, but actively, for the right conditions to transform uncertainty into structure. And behind everything we see, everything we touch, everything we believe, is something. The vacuum whispers its quiet truth. I am not empty. I am the beginning, which brings us to the most unsettling realization of all. If nothingness is this alive, this violent, this perpetually unstable, then the question that haunts cosmology sharpens to a piercing point. The universe may not have emerged from matter. It may not have emerged from space. It may not have emerged from time. It may have emerged from the vacuum itself, from the storm beneath stillness, from the energy hidden inside nothingness. And if that is true, then we stand on the edge of a cosmic paradox. Nothing is not the absence of everything. Nothing is the seed of everything. The vacuum is the cradle. The quantum fields are the lullaby. The fluctuations are the first sparks of dawn. But we are not at the end of this revelation. We have only opened the door. Because if even nothingness boils with energy, what sparked everything? To understand the universe, we often begin with its earliest moments, those ancient fractions of a second when everything familiar was still formless, trembling in a state beyond imagination. But if we continue descending, slicing time into smaller and smaller pieces, something strange begins to happen. Physics, the language we trust to explain the world, starts to whisper, then stutter, then fall silent entirely. Because buried deep beneath the Big Bang, beneath the earliest expansion, beneath even the most primitive structure, lies a moment so extreme that the very idea of understanding begins to unravel. This is the Planck era, the first 1043 seconds of the universe. A time so small, so dense, so violently uncertain that even the word era feels dishonest. For what is time in a place where time itself has not yet emerged? How do we describe a moment that cannot be measured, cannot be observed, and may not even have existed in the way we imagine? We are not just reaching the limits of science. We are approaching the boundaries of thought. To enter the Planck epoch is to step into forbidden territory, a realm where our laws fail, our equations rebel, and our intuition collapses. We are staring at the universe before the universe became something we can speak of. The journey begins with Einstein. His general theory of relativity revealed gravity as the curvature of space-time, an elegant geometric truth that explains the motion of stars and the warping of galaxies. Under normal conditions, relativity is flawless, but as we rewind the cosmic clock, densities rise, temperatures climb, curvature intensifies, and somewhere near the Planck scale, space-time contorts so violently that relativity tears apart. The geometry Einstein described ceases to exist. The smooth fabric of the cosmos wrinkles into something jagged, foamy, and undefined. It is not that relativity is wrong, it is that it was never designed for this place. On the other side stands quantum mechanics, the theory of the very small. It, too, works beautifully in its domain. It describes electrons dancing around atomic nuclei, photons flickering in the vacuum, and particles tunneling through barriers as if reality were made of mist. But quantum mechanics cannot handle gravity at extreme densities. The forces grow too intense, the energy too concentrated. The quantum world trembles under a weight it cannot hold. Between relativity and quantum mechanics lies a fracture, a gap in our understanding large enough to swallow everything we think we know. That gap is the Planck epoch. Imagine a storm so violent that space and time themselves dissolve inside it. No distance, no direction, no before, no after. Every point is everywhere. Every moment is nowhere. The universe is not expanding or contracting or even existing in the way we use the word. It is simply erupting. A quantum storm with no shore, no center, no meaning attached to its motion. The temperature is 10 million trillion degrees, a value so extreme it becomes metaphorical. Density shoots toward infinity. Energy churns in a frenzy without pattern or purpose. This is not chaos. Chaos implies rules. The Planck epoch has none. In this storm, particles cannot exist, not yet. Fields cannot settle. Forces cannot separate. The four fundamental interactions of nature, gravity, electromagnetism, the strong and weak nuclear forces, have not yet differentiated. They are merged into a single primal intensity, a unified force we do not understand. Physics becomes a kind of dream here, dissolving into fog the deeper we push into the moment. We have reached the edge of language. Scientists know this boundary intimately because their equations betray them as they approach it. Terms blow up to infinity. Curvatures spike. probabilities become meaningless. At 10 bars of 43 seconds, the universe demands a theory it does not yet possess: quantum gravity, a framework capable of merging Einstein's smooth geometry with quantum theories in jittering uncertainty. For decades, physicists have searched for this missing key through string theory, loop quantum gravity, causal sets, and speculative models. But the truth remains elusive. It is as if the universe locked its earliest memory behind a door no equation can open. And so the Planck era remains an enigma, a place where our attempts to describe reality collapse into metaphors, where even our metaphors strain under the weight of something too primal to be captured in thought. The closer we approach this epoch, the more obvious it becomes that emptiness is not the foundation of the cosmos. Before space existed, there was no emptiness to fill. Before time began, there was no before to inhabit. The void is not the starting point of creation. It is something that arrived later, after the storm cooled enough for structure to form. The Planck epoch did not contain emptiness. It contained potential, raw, violent, undefined potential. To grasp this, imagine zooming into space-time so deeply that its smoothness disintegrates. Instead of a continuous surface, you find something granular, trembling, stitched together by fluctuations at unimaginably small scales. Every point rises and falls like the crest of a wave that has forgotten it is water. John Wheeler's quantum foam becomes more than a concept. It becomes the only language capable of describing the pre-space-time world. Space is no longer a stage. Time is no longer a script. Both are actors struggling to be born from the turbulence. And yet the most unsettling truth is this: we cannot truly imagine the Planck era at all. Our minds evolved to make sense of rivers, trees, predators, and paths beneath our feet. We were not built to comprehend infinities or primordial forces fused together in a single cosmic breath. We imagine beginnings because we experience beginnings: birth, sunrise, seasons, stories. But the universe may not have begun in any way that resembles these familiar cycles. The Planck epoch suggests that the beginning of the universe was not a point, not a moment, not a boundary. It was a transition from indescribability into describability, from a state with no space or time into a realm where both could exist. In this sense, the Planck epoch is the true breaking point of comprehension. It is the border where the human mind must stop and simply witness, not because the truth is hidden, but because the truth is untranslatable. Scientists often describe the Planck scale using numbers: 10, 35 meters, 10, 43 seconds, energies beyond anything we can generate in laboratories. But these numbers function like shadows. They hint at a shape we cannot see. They point toward a landscape we cannot enter. They remind us that the Planck epoch is not merely small, it is fundamentally inaccessible. To go inside, it would require more than better instruments. It would require a new form of logic, a new type of mathematics, perhaps even a new kind of mind. And yet, despite this impossibility, the Planck epoch is not empty of meaning. It teaches us something profound about beginnings. It reminds us that the universe did not emerge from stillness, but from tension, not from silence, but from eruption, not from emptiness, but from possibility condensed into its most extreme form. What looks like a boundary to our understanding may have been the birthplace of space itself. The moment the storm softened just enough for geometry to freeze into place, for fields to settle, for forces to separate, for time to begin its long descent toward meaning. Perhaps the closest metaphor is the surface of boiling water. From above, we see bubbles forming and collapsing, shapes flickering in and out, patterns appearing for a heartbeat before dissolving back into heat. But beneath that surface lies a furious world of collisions and transformations. The Planck epoch is like staring into that boiling depth, except the pot is reality itself, and the bubbles are the first whispers of space-time struggling to take form. If emptiness cannot exist today, it certainly could not exist then. The Planck epoch makes this clear. Emptiness is a property of a cooled, expanded universe. It is the privilege of a cosmos that is calmed enough for space to stretch and time to flow. But at the beginning, there was no calm, no space to stretch, no time to flow. The question, what came before the universe, dissolves in this storm. Before requires time. Time requires space. Space requires geometry. Geometry requires structure. Structure did not exist. To ask what came before the Planck epoch is to ask what lies north of the North Pole. It is to reach beyond the map and demand an answer from a region that has no meaning to offer. And yet there is one final whisper from this primordial storm, a whisper that reaches across the ages, across our limitations, across the boundary of thought. Perhaps emptiness was never the beginning, because the beginning never had room for emptiness at all. The Planck epoch ends not with clarity, but with surrender. The surrender of chaos into something that could begin to resemble order. But the next step in the universe's story is not gentle. It is violent. It is sudden. It is the closest thing reality has ever done to shouting. Because just as the first whispers of space-time emerge from the quantum storm, the universe made a decision so extreme, so overwhelming, that it rewrote everything that would follow. This decision is called inflation, and it was the moment the universe refused to be empty. To understand inflation, imagine the entire observable cosmos, hundreds of billions of galaxies, compressed into something far smaller than a proton. Now imagine that tiny seed expanding faster than the speed of light, not because anything inside it was moving, but because space itself was stretching, doubling in size, then doubling again and again. In less than a trillionth of a second, the universe exploded outward so violently that our language buckles under the weight of the numbers required to describe it. This was not an expansion. It was an eruption, the first breath of existence, and it was not calm. The idea was born in the mind of Alan Guth, a young physicist staring at a mathematical problem that refused to behave. Cosmologists had long wondered why the universe looked so smooth, why the cosmic microwave background, the oldest light in the universe, has nearly the same temperature in every direction, even across regions that could never have communicated at light speed, why space is so flat, why structure emerged so elegantly. The old Big Bang model could not explain this. But Guth saw something hidden in the equations, a strange kind of energy, trapped in the fabric of space, capable of driving exponential expansion, a repulsive force that would push everything apart with unimaginable strength. He called it inflation, and overnight the universe became a storm of growth. This inflationary energy acted like a cosmic battery, a metastable state of the vacuum itself. Empty space in this moment held more energy than any star. It was not nothingness. It was the most explosive something possible. In the tiniest instant, the universe swelled from subatomic to astronomical scales. Structures froze into place, irregularities smoothed out. The cosmic horizon expanded far beyond the reach of light. Inflation did not simply change the universe, it sculpted it. Imagine stretching a crumpled sheet so far and so fast that every wrinkle flattens instantly. The differences vanish, the chaos disappears. What remains is a smooth, uniform expanse, ready for gravity to pull galaxies from its deepening folds. Inflation created the calm we see today by unleashing chaos at a scale we cannot fathom. Yet inflation was not a wind, it was not a blast, it was not motion in the usual sense. It was space-time itself swelling under the pressure of vacuum energy, a form of energy that does not dilute as space expands, a form of energy that grows stronger the larger the universe becomes. This is the paradox. The emptier space becomes, the more energy inflation has to expand it. Nothingness once again refused to sit still, and then just as abruptly as it began, inflation ended. Physicists call this reheating, but the name disguises a revelation. When inflation collapsed, its energy transformed into particles, heat, radiation, the ingredients of the cosmos. The universe, once smooth and empty of matter, became dense and filled with light. Quantum fluctuations, tiny ripples in the inflating field, stretched to cosmic scales, seeding the formation of galaxies, stars, planets, and eventually life. Our existence is written in the wrinkles left by the dying breath of inflation. Everything we know began in that fall. Everything we are began as a tremble in that field. But the emotional truth is deeper. Inflation was not merely a mechanism, it was a refusal by the universe to remain compressed, silent, or trivial. In that first instant, existence did not whisper into being. It roared. It claimed space. It carved time. It established scale. It lit the match that would burn for billions of years. This was the universe saying, "I will not be nothing." But inflation also carries a mystery that unnerves even the boldest scientists. What caused the inflaton field to exist at all? What triggered its decay? Why did the universe inflate in the first place? And most haunting, is inflation still happening somewhere else, endlessly, birthing new universes in a cosmic multiverse? Some theories say yes, that our universe is only one bubble in an infinite sea of inflating space. Each bubble its own cosmos, each inflated from a patch of quantum vacuum that refused to stay empty. If this is true, then creation is not a single event, but a perpetual uprising of something against nothing. But even without the multiverse, inflation remains staggering. It explains why the universe is flat, the stretching, smoothed curvature into near perfection. It explains why distant regions share the same temperature. They were once infinitesimally close before being torn apart. It explains the seeds of structure, quantum jitters amplified to the scale of galaxies. Inflation gives us a universe that feels hand-shaped, finely tuned, almost impossibly uniform. But it does so without invoking miracles. It invokes physics, relentless, unstoppable physics. Yet the philosophical implications ripple deeper. If inflation is real, it means emptiness itself contains the power to create. Vacuum energy is not passive. It is not silence. It is potential waiting to explode. The universe did not push outward from matter. Matter fell out of the vacuum's decay. What came first was not particles or photons or atoms. What came first was a storm in the vacuum, a tension in nothingness that tore itself apart to birth everything. Inflation is the universe waking up, breathing, expanding, claiming its place. And even as inflation ended, even as the inflaton field relaxed and matter formed, something deeper lingered. The vacuum continued to hum with energy, dark energy, a descendant of that early inflationary state, still stretches space-time today. Slowly, quietly, relentlessly. In this sense, inflation never truly died. Its breath still moves through the cosmos. But there is a final twist. One more. Rebellion hidden in the moment of creation. Even though inflation stretched the universe to unimaginable scale, it did not create emptiness. Space was smooth, yes. Uniform, yes. But empty? Never. The quantum vacuum still fluttered with life. Virtual particles still flickered, energy still seethed. The fields that would one day give mass to particles still waited in slumber. Inflation expanded everything, except the one thing that could not be expanded away, the refusal of the vacuum to be empty. And this is the paradox at the heart of creation. The more the universe grew, the more space appeared. The more space appeared, the more vacuum it contained. The more vacuum it contained, the more energy hummed beneath it. Emptiness was not created by expansion. Expansion revealed that emptiness does not exist. And so inflation ends not with silence, but with a question that deepens the mystery. The universe had erupted, grown unimaginably, smoothed itself into the canvas upon which galaxies would later be painted. But the vacuum beneath that canvas remained wild, restless, alive. Inflation did not calm the cosmos. It exposed the truth that would haunt physics forever. But even after this eruption, an emptiness still refused to appear. We are used to thinking of space as empty, a darkness stretching between stars, a black ocean dotted with islands of light. Even the word space suggests a gap, a void, a nothingness that separates one thing from another. But this picture, however comforting in its simplicity, dissolves the moment we look closely, because the truth is far more intoxicating, far more complex, far more alive. The universe, even in its darkest regions, refuses to give us a single cubic centimeter of genuine emptiness. Not between stars, not between galaxies, not even in the vast cosmic voids that haunt the edges of our telescopes. Everywhere we look, the universe hums. The first clue lies in the structure of the cosmos itself, the cosmic web. What appears to our eyes as scattered galaxies is actually part of an immense interwoven lattice stretching hundreds of millions of light years. Galaxies cluster along filaments like beads on cosmic strings. Clusters gather at the knots, and between these filaments lie enormous voids, some spanning hundreds of millions of light years. To the untrained mind, these voids look like nothing. They look like the universe forgot to fill them. But the voids are lying. Even in the darkest regions, matter hides. Not the luminous matter of stars or the glowing gas of nebulae, but something quieter, stranger, and far more dominant, dark matter. This invisible substance outweighs everything we can see by a factor of 5. It threads itself through filaments, wraps around galaxies, and flows across the universe like an unseen river. It bends light, it sculpts structure, it anchors the cosmic web itself. Dark matter cannot be seen, but it is everywhere. If the universe were truly empty, gravity would pull galaxies inward, dissolving the delicate structure of the web. Instead, the web persists, held together by a substance we have never touched, never directly detected, but whose presence is unmistakable in the way galaxies move. Even in the voids, Dark matter lingers in faint whispers, too thin to light but too real to ignore, a ghost that will not leave us alone. But dark matter is only the beginning of the deception. Beyond it lies dark energy, the mysterious force accelerating the expansion of the universe. Unlike dark matter, dark energy is not concentrated. It does not cluster or gather. Instead, it permeates space itself. Every cubic meter of the universe, even the emptiest one you could imagine, contains the same amount of dark energy. It is uniform, relentless, and unstoppable. It is the pressure pushing galaxies apart, the slow wind stretching the cosmos toward cold eternity. Dark energy is not in space. Dark energy is space. This means that even the voids, the great cosmic deserts, are dense with energy, not the kind we can harness or feel, but the kind that shapes the fate of existence. The emptier the region, the more dominant this dark energy becomes, steering the evolution of the cosmos in silence. So the large-scale universe is already crowded with invisibility. But let's move closer. Imagine floating between the stars of a galaxy. The distance from one star to another can stretch for light years, an expanse that seems impossibly empty. But in every cubic meter of interstellar space hides hundreds of atoms. Stray hydrogen, the leftover breath of ancient stars. Dust grains drift like lost worlds, waiting for gravity to gather them into new suns. Cosmic rays, high-energy particles born from explosions and black holes, zip through the dark with lethal speed. Magnetic fields twist and curl through the void, invisible wires threading the galaxy together. There is no silence here. The empty space between stars is alive with radiation, particles, and fields. And then we go deeper still to the space between galaxies. Intergalactic space is colder, thinner, quieter. Hydrogen thins to a whisper. Dust grains become rare. Magnetic fields fade into faint threads. But even here, the void refuses to surrender to nothingness. Streams of ionized gas flow through the cosmic web. Neutrinos, ghost-like particles that rarely interact with anything, flood every corner of the universe. Every second, trillions of them pass through your body, drifting out of supernova and the early universe itself. They move through walls, through planets, through galaxies, untouched and unstoppable. The universe is saturated with particles we cannot stop, cannot shield, cannot escape. But perhaps the most astonishing revelation arrives when we travel into the deepest voids. The places where galaxies dare not go, where dark matter thins, where atoms vanish. Surely here, at last, we will find nothing. But no, the vacuum itself refuses to cooperate. Quantum fields vibrate everywhere. Even in the coldest, most silent regions of space, the fields do not rest. They cannot rest. The uncertainty principle forbids it. Virtual particles flicker into existence. Tiny flashes of energy erupt and vanish. Photons shimmer into being and dissolve before they can be caught. The vacuum behaves less like a stage and more like a restless ocean whose waves never stop rising. Even when matter is gone, even when radiation fades, even when galaxies lie far beyond the horizon, the quantum vacuum remains. A storm hidden beneath everything, waiting. This means that the emptiest regions of the universe are also the most honest. They show us what space truly is when it is stripped of stars, planets, dust, and gas. They reveal the bare machinery of existence, a place where dark energy pushes, dark matter whispers, neutrinos stream, and quantum fields pulse with silent electricity. Emptiness is a myth we invented because the universe is too subtle for our eyes. What we call empty is simply what we cannot yet see. What we call void is merely what we do not yet understand. What we call nothing is the disguise worn by everything. And as we widen our perspective, a new truth emerges. The cosmic web is not a structure built in space. It is the structure of space. Filaments are not roads through a vacuum. They are the skeleton of the cosmos. Voids are not holes in the web. They are chambers where the invisible forces of the universe hum the loudest. The more the universe expands, the more these invisible presences dominate. Ordinary matter grows thin, stars burn out, galaxies drift apart, but dark energy only strengthens as space stretches. The vacuum becomes more influential, more spacious, more alive. The universe does not trend toward emptiness. It trends toward invisibility. And that invisibility is the true nature of the cosmos, a grand architecture whispered through forces our senses cannot detect. Even now, every atom in your body vibrates with the same quantum fields that fill intergalactic space. Every breath you take contains particles forged in stars whose light has faded. Every second, neutrinos from the birth of the universe pass through you like murmurs of a cosmic memory. You are not surrounded by emptiness. You are immersed in the universe's hidden complexity. And perhaps the strangest revelation of all is this: the quietest places in the cosmos are not dead. They are pregnant with potential, the raw, unresolved energy of existence itself. The universe is never silent. The universe is never still. The universe is never empty. And as we look into the vastness, into the places that appear abandoned and bare, we uncover a truth far more profound than darkness. Emptiness is not the absence of things. It is the presence of everything we cannot yet see. For most of human history, we pictured the universe expanding into emptiness, galaxies drifting outward into a cold, waiting nothing. It felt intuitive, almost comforting, like ripples spreading across a still pond. Something grows, something moves, something fills the blank. But the truth once again is stranger than anything intuition has ever offered. The universe is not expanding into emptiness. Emptiness itself is expanding. And it is being pushed outward by a force so subtle, so pervasive, and so deeply embedded in the fabric of reality that even today we barely understand it. This force is called dark energy, and it is the final blow to the very idea of a truly empty universe. The story begins not with a discovery, but with a surprise. In the late 1990s, two teams of astronomers set out to measure whether the universe's expansion was slowing down. Gravity should have been tugging everything inward. The cosmic web should have been tightening. Galaxies should have been drifting apart more and more slowly, like sparks fading from a fire. But that is not what the telescopes revealed. Instead, the distant supernovae they studied appeared dimmer than expected, fainter, farther away, as if the universe had been pushed harder, stretched faster, driven outward by a force no one had predicted. The cosmos was not slowing down. It was speeding up. This was not a minor adjustment. It was a revolution. Something was counteracting gravity. Something was filling space with pressure. Something invisible, omnipresent, unstoppable. It was as if the universe had discovered a new reason to grow. Scientists reached back into Einstein's equations for an explanation and found a ghost waiting for them. In 1917, long before anyone imagined an expanding universe, Einstein had added a term to his equations to balance gravity and create a static cosmos. He called it the cosmological constant. Later, he abandoned it and called it his greatest blunder. But now, decades after his death, the constant returned with a vengeance. Einstein's blunder was the universe's truth. The vacuum itself has energy. This energy does not dilute as space expands. It does not weaken. It does not fade with time. Instead, as the universe grows, the total amount of vacuum energy grows with it. Space creates more space, which creates more vacuum, which carries more energy, fueling further expansion in a self-reinforcing cycle. This is the heart of the paradox. The more the universe expands, the more of the force driving that expansion exists. Dark energy is not a substance floating through space. Dark energy is the energy of space, and that changes everything. Imagine a room that gets larger every second. Most forms of energy would thin out as the room expanded. Light would spread. Gas would disperse. Heat would fade. But vacuum energy does something impossible. As the room grows, more vacuum appears, and with it, more energy. The room expands faster and faster, not because something pushes from outside, but because the emptiness inside is not truly empty at all. This is the universe we live in, a cosmos where emptiness grows teeth. But what is dark energy, really? What is this force that fills the vacuum and commands the expansion of everything? The simplest explanation is that dark energy is the cosmological constant, a fixed amount of energy in every cubic meter of space. But deeper theory suggests something stranger. That dark energy may come from quantum fluctuations of fields that never stop vibrating. The same whisper of zero-point energy that prevents emptiness in quantum mechanics may be magnified across cosmic scales. If so, then dark energy is not merely a force. It is the echo of quantum turbulence, stretched across the universe. Other theories imagine dark energy as a dynamic field, quintessence, evolving slowly over time, shaping the fate of galaxies with its changing pressure. In these models, the vacuum is not static. It is alive, shifting subtly as the universe unfolds, as if space itself carries a memory of its earliest moments. No matter which explanation is true, one fact remains undebatable. The vacuum is not a void. It is an engine, and we live inside its slow, inevitable exhalation. The presence of dark energy reshapes our understanding of cosmic structure. As space expands, galaxies drift away from one another, but not because they are moving through emptiness. They are being carried by space-time itself, which is stretching beneath them. Galaxies beyond a certain distance recede faster than the speed of light, not because they violate physics, but because the space between us and them expands too quickly for light to bridge the gap. The observable universe shrinks even as the actual universe grows. Dark energy isolates us, expanding the darkness between galaxies until entire regions of the cosmos fade beyond visibility. In trillions of years, future civilizations, if any survive, will see only their own galaxy, floating in an apparently empty night. They will believe wrongly that the universe is small, quiet, and solitary. The accelerating universe is not merely strange, it is destined to become lonely. Yet loneliness is not the lesson of dark energy. The lesson is revelation. For millennia, we imagine emptiness as the background, the nothing against which the something of the universe unfolds. But dark energy flips this story. Emptiness becomes the protagonist. Space itself becomes the force shaping the cosmos. The vacuum is no longer a passive container, it is the sculptor of destiny. Philosophically, this is unsettling. If space creates energy just by existing, then what is existence made of? If emptiness drives the universe apart, then what is emptiness? If the vacuum has energy, structure, memory, and influence, then emptiness is not empty at all. We are forced into a new way of seeing, one where absence is a kind of presence, where nothing is a misinterpreted something, where the universe hides its most powerful forces in plain sight. And that leads us into the deepest paradox of all. The emptiest regions of the universe contain the most dark energy. The less matter there is, the stronger the influence of vacuum energy becomes. Emptiness fills itself. This inversion is one of the most profound truths in cosmology. Early in the universe, matter dominated. Expansion slowed, gravity ruled. But as the cosmos stretched and matter thinned, dark energy rose to power. It did not grow stronger. It simply became unavoidable. The universe expanded into a regime where the vacuum's energy dwarfed everything else. Dark energy is the quiet ruler of the modern cosmos. And yet, for all its influence, dark energy does not roar or blaze or collide. It acts with the gentlest pressure imaginable, a whisper that moves galaxies, a breath that reshapes destiny, a silence that changes everything. As we zoom out to the scale of billions of light years, the paradox sharpens. The universe, born from a quantum storm sculpted by inflation, woven by dark matter, now finds its fate steered by the softest force ever known, a force that arises not from matter or motion, but from the empty fabric of space itself. The universe is expanding faster because it is becoming more itself. And so we return to the illusion that began this journey, the idea that the cosmos is full of empty space. It is not. There is no such thing as empty space. Even where galaxies vanish, even where atoms fade, even where the quantum field's quiet, dark energy remains. The vacuum does not wait to be filled. The vacuum fills itself. And as the universe grows older, darker, and more isolated, dark energy will become the dominant force. It will stretch everything apart until only fragments of the cosmic web remain. It will push galaxies beyond one another's reach. It will drive the cosmos toward a future that feels cold, sparse, and hollow. But beneath that apparent hollowness lies truth. The universe is not dying into emptiness. It is blooming into dark energy. The vacuum becomes the canvas again, not through silence, but through expansion. The cosmos is not collapsing into nothing. It is unfolding into the energy hidden within nothing. And so in the end, the greatest paradox stands unchanged. The empty universe is impossible because emptiness itself has energy. From the moment our species first stood beneath the night sky, we have been shadowed by a quiet terror, the fear of nothingness. Our ancestors stared into the darkness and felt the unsettling pull of a question they could not articulate. What lies beyond the edge of existence? They filled the silence with gods, with stories, with firelight and myth, because the alternative, the idea of a true, absolute void, was too enormous to bear. The human mind was not built for emptiness. It was built for presence, for patterns, for meaning. And yet the night kept reminding us of what we did not know. The centuries passed, but the fear remained. Greek philosophers debated the nature of the void with trembling logic. Aristotle banned it outright. Medieval scholars declared it impossible. Even the early scientists, armed with mathematics and courage, hesitated before the idea of a universe that contained regions utterly empty of matter, motion, or purpose. The void was an abyss, and to gaze into it was to risk losing oneself in infinite absence. But this fear, ancient as breath, hid a deeper truth. Emptiness is not a property of the universe. It is a projection of the limits of our imagination. Every step forward in physics, every breakthrough, every revelation, has not revealed an empty cosmos. It has revealed a cosmos more alive, more full, more restless than anyone dared imagine. The quantum vacuum seethes with fluctuations. Fields vibrate in perpetual motion. Space itself expands with energy that cannot be erased. At cosmological scales, dark energy fills every cubic meter. At microscopic scales, quantum foam ripples through the foundation of space-time. We expected silence. We found storms. We expected absence. We found structure. We expected nothing. We found the origin of everything. Slowly, painfully, beautifully, the universe dismantled the illusion our minds clung to. The void was never real. It was a misunderstanding born of scale, a human-shaped shadow cast onto a cosmos that does not share our intuitions. When we look out into the night and say there is nothing there, what we truly mean is there is nothing there that our senses can perceive. But the universe is under no obligation to operate at human resolution. The final realization begins with humility. We believed emptiness existed because our minds demanded simplicity. We wanted the universe to be clean and comprehensible, a stage upon which matter and energy performed their cosmic drama. But nature does not grant us such comfort. The vacuum has energy. The vacuum has fields. The vacuum has fluctuations. The vacuum has structure. And if the vacuum possesses all these things, then the vacuum is not empty. The deeper we look, the more this truth expands. Consider the quantum fields that fill all of space. Even with no particles, no radiation, no heat, these fields cannot be perfectly still. They flicker with zero-point energy. They spawn virtual particles. They churn with uncertainties that cannot be smoothed away. Even the emptiest region of the universe is a sea of infinitesimal creation and annihilation, a perpetual dance on the edge of existence. This alone destroys the idea of nothingness. But the universe goes further. Dark energy, the quiet force accelerating cosmic expansion, fills every corner of space. It does not dilute. It does not weaken. It grows as the universe grows. It is not a background. It is the engine of evolution. Even if all matter evaporated, even if every star died, even if every particle decayed, dark energy would remain, stretching reality into new shapes. Emptiness, in this sense, spreads but never appears. Even the largest cosmic voids, those great black hollows between filaments, are not truly empty. They contain dark matter, weak gravitational tides, intergalactic particles, radiation from the Big Bang, and the eternal hum of quantum fields. What looks like nothing is always something. So why do we cling to the idea of emptiness at all? Because the human mind evolved in a world of objects, trees, rivers, faces, predators. Our senses were tuned for survival, not for cosmic truth. To us, a room without furniture feels empty. A field without trees feels empty. A night sky without clouds feels empty. But these are interpretations, not realities. The brain compresses complexity into simplicity. It filters the unseen. It erases what does not matter for immediate survival. Emptiness is not a physical truth. It is a cognitive illusion. Throughout this documentary, we have traveled from ancient fears to quantum storms, from inflationary outbursts to cosmic webs, from virtual particles to dark energy. Each step strips one more layer off the illusion. Each revelation pushes us further away from the idea that the universe ever contained nothing. When the universe was young, unimaginably young, it was not empty. During the Planck epochs, it was a storm of undefined geometry. During inflation, it was a furnace of vacuum energy stretching space beyond comprehension. When matter formed, neutrinos filled the cosmos. When stars ignited, radiation flooded the voids. When galaxies evolved, dark matter shaped their paths. And today, 13.8 billion years later, dark energy pulls everything apart while quantum fields whisper beneath reality. At no point in this story did emptiness appear. Not at the beginning, not in the middle, not in the distant future. The universe is allergic to nothingness. This realization carries profound philosophical weight. For centuries, humans believed that emptiness was an option, a state the universe could fall into, a possibility lurking beneath existence. But now we understand the opposite. The universe cannot be empty because emptiness is impossible. The laws of physics do not allow it. The structure of reality does not permit it. The energy of space prevents it. The quantum fields forbid it. Even the concept of nothing collapses under scrutiny. Nothing is not a state. Nothing is not a place. Nothing cannot exist because nature has no mechanism to create it. And so the void becomes not a feature of the universe, but a mirror for the mind. It reflects our limits, not the cosmos's. It reveals the distance between what the universe is and what our intuition imagines. We sought nothingness because we needed boundaries. We feared nothingness because we misunderstood existence. But the universe, indifferent to our fears, moves with its own logic. A logic that never once makes room for emptiness. This brings us to the final transformation, the realization that emptiness was never out there. It was always within us. Our ancestors named the void because they felt the edge of their knowledge. Philosophers filled it with arguments. Mathematicians filled it with symbols. Astronomers filled it with darkness. But physics fills it with structure, with energy, with meaning. The universe is not empty. The universe is full beyond measure, full of what we cannot see, full of forces we cannot touch, full of truths we are only beginning to understand. To imagine the universe as empty is to imagine the ocean without its currents, the forest without its roots, the body without its breath. It is to strip away the invisible scaffolding that makes existence possible. The vacuum is not absence. It is the foundation. It is the medium of creation. It is the canvas upon which everything else is painted. And so we arrive at the quiet end of our journey. After all the revelations, all the paradoxes, all the discoveries that shattered intuition, one truth remains. Emptiness is not a cosmic reality. It is a human story, a myth born from the limitations of perception, a shadow cast by a mind that evolved to grasp objects rather than energies, surfaces rather than fields, light rather than the invisible depths beneath it. When we let go of the illusion, something beautiful happens. The universe becomes larger, stranger, more intimate. We realize that we are not suspended in nothing. We are immersed in an endless ocean of existence. Every point in space, no matter how dark, holds forces older than time. Every silence is filled with hidden motion. Every void is alive with energy. The universe can't be empty. It never was. And as this realization settles, a final silence emerges. Not the silence of nothingness, but the silence of understanding. The silence of a mind finally shedding an ancient illusion. The void was never the universe. It was only the limit of our imagination. In the beginning, we thought emptiness was the canvas, the quiet stage on which the universe placed its stars, its galaxies, its stories. But after traveling through quantum storms, inflationary bursts, cosmic webs, and the silent tides of dark energy, something becomes unmistakably clear. There is no canvas of nothingness. There never was. The universe does not sit within emptiness. It grows from a foundation that has never once been empty. The void we feared was only a misunderstanding, a shadow drawn by minds that evolved to see surface, object, light. But beneath the surface, beyond the objects, within the darkness, the universe hums with ceaseless presence. Fields ripple, energy whispers, space expands with a force older than time. Even the quietest corner of creation contains the full weight of existence, and so the paradox dissolves. Emptiness was never the opposite of being. It was the illusion that blinded us to how full the universe truly is. When we release that illusion, a strange peace emerges, not the peace of silence, but the peace of understanding. The universe does not grow by adding more stars. We grow by letting go of the idea that there was ever nothing between them. In this final moment, the journey circles back to its beginning. We thought we were staring into a void, but the deeper we looked, the more the void opened into wonder, a revelation that emptiness is impossible, that existence cannot be quieted, that the universe refuses to be anything less than full. And with that realization, something shifts within us. The universe was never empty, and now neither are we.